Today we are going to solve a crystallographic data collected by APEX question instrument. Now we are using APEX4 software to solve the data. So for that, first we will open APEX software. Now we go to our sample folder where data stored. Then press new. Write here your sample name, suppose sample 1, like that, sample 1. Now we paste the directory link, then press OK. Now here you see some icons. So among that icon you press on evaluate. Okay, then go to the determine cell, unit cell. So press that icon here, known as open image. It will redirect you to the folder. So these two are folder are already solved. So we are starting fresh solving data. Then we click on the first image. It will load all the images, and you can see the spots. The spots are not too good. Crystal quality may hamper. So you can see the pattern and some problem in the spot. Still we will proceed. Then go to the harvest spot. Here we put number of images 1 and go to images. By default per run is 180. And by seeing observing the spot, we can set mean array sigma. Let it be around 20. We click on save only reflection that span images. Then start harvesting the spots. It will harvest all the spots falling in the range of mean array sigma more than 21.06. Then go to index. It will indexing all the spots present in all the frames. Here the mean array sigma will be same as in taken in harvesting. So we just click on index. It will index all the spots and find what is the cell parameters like A, B, C, alpha, beta, gamma. In our data, the alpha, beta, gamma is 106 degree and 90 degrees, and our cell volume is 7,427 angstrom cube. So by this here this is the first Fourier transform method, and the first taken was method of difference vectors. Here data was quality is very low, so we reject it and accept this first Fourier transform. Then click on accept. Okay, then you can set the tolerance to 1 and click 2 or 3 times on refine. It will refine the data, and you check that your ESD values are fine and not changing upon more refinement. So just accept it. Now you go to Bravis. Okay, Bravis will show you how all the possibility unity cells that accompany with that data. So here orthorhombic, monoclinic C and triclinic P are may possible for this data. Now the software tell us to choose orthorhombic, so we'll accept that orthorhombic unit cell. Okay, then go to refine. Just refine it, set the tolerance to 1 and start refining 2 or 3 times, then accept. Now the part of determining unit cell is complete. Now we will integrate all the data. So for this, go to the reduce data tab, and in the reduce data tab you can see several icons such as integrate image, crystal, index crystal faces and scale, like that. So first we will integrate all images. We have taken that 180 images. For one frame there are 7 frames, so we integrate all the images present in all 7 frames. So each frame has 404 images. There are 7 frames. So we choose all the frames and just start integration. Okay, then it will integrate all the images, all the spots present in all frame images and all frames. So you can see there is some progress of integration. Okay, now I will show you that in real time, the integration process in real time, by which you know the actual time it takes to integrate all the images. Now the data quality is average, good quality you can say. You can see that lines and that progress of the integration. You close to the monitor and you can see that real-time analysis of that data. It will take few minutes. After that we will proceed to next step. And the refinement result here you can see in that how many spots are integrated in which folder, like that all the informations are below. And this is the average spot intensity versus image, and this is the error versus image graph, and this is the average correlation coefficient versus image. This is the snapshot of each images taken by the instrument. So this integration is going on. Now it will proceed. Some lagging in the software maybe. Okay, now here the close button is on, so that it means integration is complete. We close the integration, then we will go to the scaling of the data. So in the integration part we integrate all the frames, and there are some raw files are generated. Okay, now in the scaling tab we will scale all the raw files present in all the frames. So there are 7 frames. For each frame one raw file, then so there are 7 raw files. We will choose all the 7 raw files. Here the log group and point group will be as per the determine unity cell. In case of determine unity cell we choose orthorhombic. For orthorhombic it will be MMM. If it was triclinic, then you have to choose -1. For monoclinic 2/m and so on. So for our system unit cell is orthorhombic. Space group and point group will be MMM. Log group and point group will MMM. Then we will start scaling process. In scaling process you will see all the values of the data. It integrate, and in terms of mean by sigma, number of groups versus redundancy. So you just refine it, and you see the next page. Since data quality is not too good, and that's why we got a graph like this. Then we go to next, then we finish this process of scaling. After that next go to the examine data. In examine data there are several tabs like determine space group, analyze data in XPREP. Both can be used to determine unit cell. So we go to the determine space group. Then determine space group we choose that SQL file generated after scaling. After scaling, the SQL file what will generate. We'll choose that SQL file, and the P4 file also be there, which is generated after integration. So both file we will choose, and we put our elements present in the compound. Let's our compound contain H, C, N, Cl and palladium. So we'll go to the restart button. It will restart determine space group process. Then press next. Then press next. Okay, there's some error. So there is space group selection is there. If your molecule is centrosymmetric, you can select this space group. If non-centrosymmetric, you can press this space group. So it will by default it take centro. So we will go for next. And then press next. Here you can see some parameters of your data, that like resolution, completeness, redundancy, mean by sigma, R integral, R sigma. This green color suggests the good quality, and that orange color moderate quality. If completeness is 100% or more than 97-98%, it will be green. So there is some quality low in the data, so we'll press it is over now. Then we'll go to the find structure. In find structure there are 4 tabs like auto structure, solve structure, refine structure, view structure. First we will solve the structure, then press on that solve structure, then it will redirect you to that folder where your HKL file, P4 file or stored. Once you check again it is correct or not, then you find that one HKL file is generated and that one was selected and all others are selected. You put your value here for Z or leave it as by default, no problem. So you then click on solve structure, it will solve the structure automatically. Now after few minutes you can see the structure. If the data is good, the structure will be good, otherwise you see a broken structure. Now the structure is generated by the software, and there are three structures present in one unity cell. So you can see the structure. Now go to the refine and press here that copy res to INS file and refine with Excel. It will generate your INS file and other necessary file needed for next refinement. So then you refine here also, like refine structure tab, and you can go to SHELXT from here or just click on the SHELXT and load the files in SHELXT, by which you can able to see the structure in SHELXT window. In the interface present the structure. Here you can also generate that zip file which is necessary for crystal data. So you press refine and click on full matrix, and here check in that generate acta. That acta will generate zip file for you. Okay, then you take the suggested values and just press refine, and now it is refined. Here you can see the data values of your R1, WR2, goodness of it, like that. Then you go to that folder. That folder will contain your all the necessary files. Here you can see that FC file, INS file, your all the necessary files are there. Okay, thank you. Stop. हो गया भाई।